Nachiket Gupta. Can you just brief about yourself, Nachiket?
Sir, myself Nachiket Gupta. I belong to Jammu and Kashmir. I did my schooling from Kendra Vidyalaya Bantla. In 2015, I passed my 12th. After that, I cleared my state's engineering entrance exam with the rank of 507 and entered the State Engineering College, Government College of Engineering and Technology, Jammu, to pursue my bachelor's in mechanical engineering. In the fourth year of my college, I did my industrial training under Asian Motors Private Limited, and my final year project was we built a solar car, so electric car to be precise. And my father was a medical officer in the state health and emergency services, and my mother is a employee of the JNT.
Okay, so in which year you pass out?
Sir, I passed out in the year 2019.
2019. After that?
Yes, sir.
After that?
So after that, I started preparing for various government entrance examination, including the ones which are engineering based, for like GATE and ES, etc.
Have you qualified any other exam also?
So this year only I have qualified HPCL, and I have also qualified for SSC JE and the state JKP Jammu Kashmir Public Service Commission Assistant Engineers exam also.
What's your marks in SSCJ?
Sir, my marks actually they have not given out their marks right now, I think, but my raw score was around 125.
125. Okay, okay, it's a good score.
Okay, sir.
इस बार काफी लोग सेलेक्ट भी हुए हैं उसमें, तो सीट्स भी
Yes,
अच्छी हैं
sir.
इनका. Okay.
Okay, sir.
So do you want to give a snap of a strength of material? Okay, am I correct?
Yes, yes, sir.
Okay, just tell me why we use the Moore circle. What's the need of a Moore circle?
Sir, Moore circle is basically a graphical representation of principal stresses. Like if we are, अगर हम एक बॉडी पे सर डिफरेंट डिफरेंट तरह से स्ट्रेसेस लगा रहे हैं, लाइक साइमल्टेनियसली उस पे एक एक्सियल लोड भी लगे एंड एक शेयर लोड भी लगे, सो जो बेसिक सॉम इक्वेशंस है वो वहाँ यूजफुल नहीं रहती. टू सॉल्व दैट इक्वेशन प्रॉब्लम we need to consider principal stresses, because finally we don't want the our specimen to fail. So उससे बचाने के लिए हमें वो पोजीशन ढूंढनी होती है जहाँ पे मैक्सिमम स्ट्रेस अवेलेबल हो. सो सर उसको ग्राफिकली रिप्रेजेंट करने के लिए हमें मोर सर्कल काफी हेल्प करता है बेसिकली. यस सर.
So if I am just talking about how the Moore circle will be drawn in case of pure shear stress.
Sir, in case of pure shear stress, it will be a circle whose center lies at the origin, and it has radius equal to the applied shear stress.
Okay. If I am going to draw a Moore circle for a fluid at rest condition, so how it look like?
Sir, for a fluid at rest condition, it will be a point that would be on the positive x-axis.
Are you confirm on positive? Why in positive?
Uh, Sir, it would be on the x-axis, but I'm doubtful about being on positive or not, because there will be no shear stress in the specimen,
Okay.
in the fluid element.
So what do you mean by in-plane Tomax and absolute Tomax?
Sir, in-plane Tomax basically represent the plane that we are considering. What is the maximum value of shear stress that can occur जो उस plane में sir available होगी हमें. But absolute Tomax we are talking about the whole body की जो हमने पूरा specimen consider किया उसमें shear stress की maximum value क्या हो सकती है sir?
Okay. So can you just tell me what do you mean by a fatigue load?
Sir, I couldn't
Fatigue
hear
load,
it.
fatigue load.
Fatigue load. Sir, fatigue load is just a moment, I'm recalling it. Sir, fatigue load. Sir, it is a type of load that is not gradual or suddenly applied. It will be alternating. It can be alternating or completely reversible. Any load that changes its value during its application.
So if I'm just taking the I section and apply the transfer shear load, how the shear stress going to vary?
Sir, in the longer bars, the longer horizontal bars of the I section, the shear stress will be least. But once we consider the area that is in the flange of the section, the shear stress will take a sudden jump, and it will then follow a curved value, and same for the section beneath the
Where it
neutral
is
axis.
maximum? Neutral axis.
No, sir. It is maximum at the junction of flange and the web.
In the case of T section,
So in the case of T section, it will have a it will have similar sorry sir, it will have similar variation, but the thing is, since there is no flange section on the bottom, it will continue to uh, form a curve at the end.
so its variation is linear, or how it's vary?
So its variation is not linear, it can be parabolic, I think.
Why?
Sir, because as we go by the formula of shear stress, tau equal to PA y bar divided by I N A B. So it can, if we keep the load constant, so it depends both on area and sorry sir,
Mhm.
and inversely proportional to the neutral axis. So the value of neutral axis for the various sections will change. So that is why it will form a parabolic area.
So यहाँ से पैराबोलिक कहाँ आ रहा?
Yes sir.
यहाँ से पैराबोलिक का कहाँ इक्वेशन बन रहा?
सर
लिख के देखो एक बार जरा जो आपने बोला. If you have a
okay,
pen.
tau equal to P. Sir, since tau is inversely proportional to neutral axis. Sorry, I'm unable to recall this. Sorry.
Acha, if I just want to see a variation of a bending stress in the case of a circular section, so how it is
Yes, sir.
going to be vary?
Sir, it will vary linearly from cross section to the cross section, and it will have a maximum value at the extreme ends.
Okay. So it is minimum at.
So it is minimum at the neutral axis, because the section is symmetrical above and below the neutral. It will be minimum at the neutral axis.
एक मिनट just hold on. Huh?
Sure, sir.
Okay. So if I'm just applying the load, just like eccentric load, है ना? Eccentric
Yes, sir.
axial tensile loading. In that case
Uh,
of bar.
eccentric axial tensile loading. Yes, sir.
In the case of bar. Okay.
Yes, sir.
So eccentricity की value है dy4.
Yes, sir. D by 4.
ठीक है. Are you understand where the load is going to be at?
Yes, sir.
So where is the neutral axis now? It is
Sir,
same.
is this applied load a compressive load or a tensile load, sir?
Eccentric axial tensile loading.
Okay, tensile load. Okay. So since on the section, since there is a tensile load, we can consider this equivalent to applying a load, direct tensile load, and moment of and equal and combination of tensile load and a bending moment, sir. So the section will shift towards the neutral axis, will shift towards positive. So the neutral axis will shift to, if the load is applied on the upper region, the neutral axis will apply opposite. The neutral axis will shift towards the opposite side, sir. जो opposite side हो गया जिस पे load, suppose अगर हम दो sections कर ले, upward and lower, so the neutral axis will shift towards the lower side, sir.
So it is different from the centroidal axis, or same?
Yes, it will be different from the centroidal axis.
Okay. Nishita Gupta, I will just give you the feedback about your mock. Really, you are a good student. Your way of delivering is also good. You have a good knowledge about the subjects also.
थैंक यू
Little
सो
bit
मच.
small things, just like जैसे कि मैंने आपको shear stress का पूछा, बस वहीं आप थोड़े से अटके हो, बाकी कोई मुझे इशू नहीं लगा. और वो भी जो आता है ना, आपने पढ़ा होगा फॉर्मूला 6p अपॉन पाई डी क्यू, ब्रैकेट में d/2 का स्क्वायर माइनस y स्क्वायर,
यस सर, यस सर.
वहां से आता है जो वेरिएशन होता है पैराबोलिक, है ना. तो बस
ओके
एक
सर.
यही क्वेश्चन मुझे लगा जहां आप थोड़ा सा लैग किए थे, बाकी हर जगह आपके आंसर अच्छे थे, अप टू डेट थे. सो देयर इज नो एज सच इशू. व्हाट्स योर इंटरव्यू डेट?
सर इट्स ऑन 1st March 23rd.
सो डेफिनेटली यू विल बी सक्सीड, देयर इज नो इशू, है ना. और एनी टाइप
थैंक
ऑफ
यू सर.
regard to us, so please just call me, or just, if you want to do some more snaps, so you can just join next time, है ना. Okay,
ओके
thank you
सर.
so much
सर
for joining.
सर
हाँ
इफ आई मे आस्क समथिंग. सर फ्लुएंसी ठीक थी मेरी?
हाँ हाँ, कोई इशू नहीं है.
इंग्लिश
नेचुरल
इंग्लिश
है.
इम्प्रूव
ना ना
ज्यादा
ना,
करने
नहीं
की जरूरत?
नहीं नहीं, ऐसा कुछ नहीं है.
चलिए ठीक है सर,
ओके,
ठीक है. ओके, थैंक यू.
थैंक यू सो मच.